Welcome to qnawire.
Okay, so we're being asked to find the local max and min using the first and second derivative test, and then it's asking which method do you prefer. So I'm just going to show you both methods, and that's going to be kind of up for you to decide. And I'll kind of talk a little bit about the advantage and disadvantage for both of them. All right, so using the first derivative test, we have to first take the first derivative. So we take f prime of x, and then this gives us 6x minus, oops, 6x minus 6x squared. There's a common factor of 6x, so you can fold that out. That leaves us with 1 minus x. We set this whole thing equal to 0. So we get x equals 0 and 1. Then we create a sign chart to figure out how the function is behaving. So we're going to evaluate it at 0, at 0 and 1, and draw a line straight down. And we're going to look at the parts of the function 6x and 1 minus x. And then when you multiply together, you get the sign of f prime. So 6x will be negative, positive, positive. And then this will be positive, positive, negative. Now you multiply this through, and then you get positive times negative is negative, positive times positive is positive, and positive times negative is negative. So that means, so we can look at how the function is acting at this point. So we can say it is decreasing and then it is increasing. So that means when it's increasing and decreasing, we have a local min. So we have a local min at x equals 0. And then we see that the function is increasing, increasing, and then decreasing. So we have a local max at 1. So that is how we find the local min and max using the first derivative test. So then for the second derivative test, what we're going to do is we first take the second derivative, and then what we're going to do is it gives us 6 minus 12x. And I think the best way to do this is we first look at the points in which where f prime was 0. So f prime was 0 at x equals 0 and x equals 1. And this is relevant because the reason why they're 0 is because the sign changes. So that means that in order for the sign to change, there has to be a point where the slope is equal to 0. And so we know that the slope equals 0 at 0 and 1. So then we take those 2 points and plug it into our second derivative. So we evaluate f prime of 0 and f prime of 1. And so 6 minus 0 is 6. And then this will be 6 minus 12 will be negative 6. Since f prime is positive, we know that it is concave up. So concave up, which means it looks something like this. So that means there's a local min. So local min. And then if this is concave down because it is negative, concave down, it looks like this. So there's a local max. And that is how you determine the local mins and max. So for me, personally, I prefer this method, the first derivative test, because it just makes more intuitive sense to me. And the second derivative test seems like it's just an extra step, and it really uses information from the first derivative test. So, and you can kind of see that there is a concave up shape by just looking at how the function is behaving. So you don't even really need the second derivative test. I feel like it's an extra step. It's an extra derivative. But if it makes sense to you, by all means, whichever works best for you, I believe. So essentially the first derivative test, I feel like is a faster way to do it. But if the second derivative test makes sense to you, then use it.